Today we are going to talk about ionization of acid, which help us to find the Ka value and then find pKa value to help to find the strengths of acid and base. Then we're going to show you some organic acids and bases and how we can find Ka and pKa value relationship to the strengths of acid and base. Look at here, guys. Here we have an acid and a base. Based on Bronsted-Lowry definition, acids donates hydrogen. So you can see that Ha becomes A minus. So these two will be conjugate acid-base pair, and then H2O and H3O plus gonna be another conjugate acid-base pair, which have only one hydrogen difference. We can also find the Ka value, which is going to be based on the equilibrium expression, products over reactants, which we can see that when acid dissociates in water, it's gonna make hydrogen ions or hydronium ion and conjugate base of it. So the more we have these ions, the more the strength of the acid is going to be. We can conclude that the higher the product, which are these ions, is going to give us higher Ka value, which is going to give us a stronger acid. So this is a very straight relationship between these ions and Ka value and the strength of acid. What about the relationship between pKa value and Ka value? You can see that because pKa value is easy to use and is more widely used, they use pKa value instead of Ka value, because it's just some numbers and it does not have some, to the power of 10 value, so it's easier to follow up and to follow it. The pKa value is the negative logarithm scale of the Ka value, which we got it from equilibrium expression. Strong acids have pKa value at 0 or below because the scale that we're going to use to find the pKa is a negative logarithm and is inverse logarithm. The lower the pKa value is going to be a stronger acid. We can conclude that the higher Ka value and lower pKa value tells us that we have a stronger acid. Let's go and see what are weak acids and bases. And here we're going to talk about weak acids. Weak acids dissociate incompletely, and strong acids dissociate completely. Also for the bases, weak bases dissociate incompletely, and strong bases dissociate completely. So when acid dissociate completely, it's going to be a strong acid. Look at here. We can see here HCl, hydrochloric acid, which is a strong acid. When it dissociates in water, it completely dissociates and is surrounded by water molecules. These are some Ka values. You can see that the higher the Ka value, the higher the strength of the acid. What about the strength of base? Strength of base is measured by the acidity of the conjugate acid. By knowing that pKa plus pKb equal to 14, we already have gotten it from auto-ionization of water. And we have this equation that when pK of acid and pK of B added, they should be equal to 14. If we consider the first one as a pK of acid, conjugate acid, and the pKb of its base, you see that they are related to each other. One should be the subtraction of the other one from 14. So the stronger the conjugate acid, the weaker its base. So the stronger, they are opposite to each other. The stronger the conjugate acid, the weaker its base. You can see here the pKa value when it's gonna be lower. For example, imagine is 1, the pKb is gonna be 13. So they are gonna be opposite to each other. The weaker the conjugate acid, the stronger its base. You can see here that again is opposite. The stronger the base is going to be the lower the Ka value and the higher pK value for bases. For acids, it was opposite. Higher Ka value and lower pKa was giving us a stronger acid. Look at here, we can have an example here. HCl is a strong acid. We talked about it today. So its conjugate base is going to be a weak base. Look at water, is a very weak acid. Its conjugate base, OH minus, is completely opposite. It's going to be a strong base. Here, look at here, there are some organic acids and organic compounds. They compare the acidity of them. When you look at the pKa value, the lower the pKa value is the stronger acid, and the higher pKa value is going to be weaker acid. Only by comparing their pKa value, you can find which one is the stronger acid and which one is the stronger base. For the pK, again, these are some bases. You can see that the higher the pKa is going to be a stronger base, and the lower pKa is going to be weaker base. It's opposite to the acids. In summary, the strength of a Bronsted Lowry acid is determined by the extent to which it ionizes in water. We showed it, and how the more we produce ions, which is dissociate completely, we have a stronger acids, and when these dissociate incompletely, we call it weak acids. A strength of bases is measured by the acidity of their conjugate acid. At the larger decay and lower pKa give us a stronger acid, and the smaller the Ka value and higher pKa value give us the stronger base.